Greetings, glad to be here once again. We're going to give you a little bit of an exercise in IPCC's self-contradiction. So a couple of introductory notes. I will not tell you that my climate model is better than the others. I don't have a climate model. That's model inequity. There ought to be a law. I'm going to be using intellectual jujitsu here. Intellectual jujitsu amounts to using IPCC's analysis and data against IPCC's analysis and data. And I apologize to the giants in our field, many of whom are in this meeting, that their data is probably better than what the IPCC has, but the intellectual jujitsu paradigm requires that I stick with the IPCC data. I'll begin with some terminology here, which is a little bit confusing. I don't know if it's deliberate or stupid, but in any case, you'll see at the top there, it says radiative forcing delta F in watts per square meter. That's very curious because the delta would imply that it's a change in radiative forcing, but they just use the term radiative forcing. And right away, you begin to have a little confusion. So I'll show you a picture which sort of indicates what I'm talking about here. That sounds pretty ominous, but here's the picture. There's the greenhouse effect, and there's radiative forcing. The greenhouse effect from the IPCC is 159 watts per square meter at the present time. The radiative forcing due to doubling CO2 would be 3.7 watts per square meter. That's a little over 2% increase. Another thing is that everything in the IPCC is referenced to the pre-industrial period of 1850 to 1890, and with apologies to paleoclimatologists and so forth, they're going to ignore all the dinosaurs and the PT extinction and all that kind of stuff. Okay, so everything is referred to that particular pre-industrial period. That's talking about CO2 in the atmosphere, the temperature rise, and radiative forcing. In other words, there was zero radiative forcing in the period 1850 to 1900. Now I'm going to this is copied verbatim from the IPCC. Radiative forcing is the change, and I emphasize change, in the net downward minus upward radiative flux expressed in watts per square meter due to a change in external driver of climate change, such as a change in the concentration of carbon dioxide. Now, most ordinary mortals would think that carbon dioxide is not external, but after all, most mortals are not in the IPCC. Concentration of volcanic aerosols in the output of the sun. I'll translate this gobbledygook into this. That is, changes in radiant flux due to changes in greenhouse gases, albedo, and sunlight, all with respect to that pre-industrial period. Okay, now I'm going to show you a heat balance drawing from AR-6. That's the, what do you call it, the assessment review. Assessment report number 6, which was published in 2021. That's a heat balance diagram, and there are numerous examples of the conservation of energy in there. For example, the sunlight that comes to the Earth is equal to the absorbed sunlight plus the reflected sunlight. The net amount of absorbed sunlight equals the amount of radiation that goes into outer space in watts per square meter. The heat that goes into the air, into the atmosphere, equals the heat leaving the atmosphere. The heat that goes into the surface equals the heat that leaves the surface. So they have these examples in here, and there are a total of about a dozen numbers. In fact, I think I counted there are 12. But wait, there's more. There's a blank region in there. And what is missing there? Why is that region blank? They've got an arrow pointing to a nothing. Now I'm going to tell you about what that missing number is. What is IPCC's specialty? Anybody? The greenhouse effect. Do you agree? What number is missing from the heat balance charts? The greenhouse effect. I'll show you. It only took them 31 years to ascribe a symbol and a number to the greenhouse effect. I sort of secretly think that maybe somebody who wrote this particular thing was a bit of a climate skeptic, and he didn't want to say anything that the political masters would recognize as being contrary, so he wrote a very complicated paragraph. Or it could just be stupid, I don't know. Anyway, the greenhouse effect, G, is the numerical difference between the surface radiation and the radiation to space. And God forbid you should have it in a heat balance chart. But here you come. Here is this interesting paragraph from AR-6. At this point, you'll notice it says the greenhouse effect G, and there down below it says G equals 159 watts per square meter. And down here it says sigma is the Stefan-Boltzmann constant. That, my friends, is the first, number one, example of mentioning, in fact, it's the only mention of the Stefan-Boltzmann equation, which is not given, in 31 years of activity at the IPCC. We'll get back to that. You are going to see what the Stefan-Boltzmann equation is. But in any case, we're going to put that greenhouse effect in there where it belongs. It's 159 watts per square meter. Okay. There's 159, which is the difference between the surface radiation and the radiation to space. Simple arithmetic. Figuring out that the greenhouse effect is 159 watts per square meter is the province of real experts like Will Happer and William Van Weingarten. And they may have slightly different numbers and so forth, but we're going to show you a little bit about that. Here is a visual explanation. The radiation to space, that's a spectral plot. It's intensity versus reciprocal wavelength to the right. The intensity of the radiation that goes to outer space on the left is equal to that nice, smooth, black body radiation coming off the surface minus the greenhouse effect. Okay? Very simple. Okay, there we go. So here's the conservation of energy. I'm going to give you two examples. The first one is that in equilibrium, the amount of sunlight that's absorbed, I in, equals the amount of radiation that goes to outer space, I out. And you can see there the difference between 340 and 100 is, or between 100 and 340, is 240. And down at the bottom, they see a little bit of an imbalance of 0.7. And, well, that's a big maybe. It's really, really hard to measure something like that. To give you an example, you can't measure that number directly. Imagine measuring the distance between your feet and the moon, and the distance between your head and the moon, and subtracting to find out how tall you are. You might find out that you are minus 680 meters tall. So it's a very, very dicey number, and you'll notice that these numbers are fairly uncertain. But here's the other equation, that I out is equal to I surface minus G. And those other things are internal energy transfers, which require a certain amount of expertise, but we're going to ignore them because we're simply going to take their numbers as answers, okay? So now we have two equations, I in equals I out, and I out equals I surface minus G. And those numbers that you see there are the ones that matter, and we'll proceed from there. Let's do the trivial algebra. Anybody in the 6th grade that can't do this algebra ought to be taken out and shot. I don't mean that. Teachers maybe. Anyway, I in equals I out, and I out equals I surface minus G. All we have to do is equate those two. I in equals I surface minus G. That's a very, very, very important equation. Now, we're almost there. Where do we get that number 398 that was in that graph? And the answer is we get it, it's calculable from the surface temperature. That's the most important thing to know. The second most important thing to know is that Stefan-Boltzmann law is the one that tells us. And then we'll show you later what the actual equation is. But the answer is that 289.45 kelvins, which is 16.3 Celsius, is the temperature that would give rise to that 398. You can always find the Stefan-Boltzmann law on the internet, but important rule, do not get yourselves wrapped around the axle about pretentious precision. In other words, you look at that 398 watts per square meter, that's, well, maybe it's as low as 394, maybe it's as high as 400. Got it? Okay, now we come to an important concept. What happens if I in remains constant as the CO2 rises? In other words, we have I in equals I surface minus G. I in equals I out, okay? I in is whatever we receive from the sun minus what's reflected. I surface, you calculate from the Stefan-Boltzmann equation, and G is what they tell you, okay? So there's I out. Now, if I in remains constant, that means the left-hand side of the equation remains constant. Therefore, the right-hand side of the equation remains constant. And what that means is, if there is an increase in G, it has to be matched exactly by an increase in I surface. I mean, this is simple, okay? It's really simple, but ignored. Now, comes a challenge to your favorite climate guru. And you have to ask a polite question. Well, what about heat balance charts for the future? Because all of the assessment reports, with the exception of the first one in 1990, had heat balance charts. So here is the complete set of heat balance charts for the future. None. And that's important. So you might be seeing where you can make yourself a buck. What you've got to do is challenge your climate guru to make a heat balance chart for the future and put it in the form of a wager. Make it worth their effort. So here is a $10,000 wager, but it's for real suckers. And it works like this. I'll bet you $10,000 you can't find even one heat balance drawing made for any year past 2021 in any IPCC assessment report. There is no such chart, and no climate scientist that knows anything would take you up on that bet. But here's one where they might take you up on a bet. $1,000 wager. Guru, pick a model, any model. Pick a time, any time. I don't mean tomorrow, but sometime in the future, okay? Now, let me tell you something about models. The RCP has been put in the past, and now they use SSPs, but the graph there is showing the amount of carbon that might be emitted in the future, just depending on what kind of things politicians do and people respond. And this is a graph that has some RCP numbers in it, but it has a whole bunch of models based on those things. So by that last one, it was Arlo Guthrie. You can get anything you want at Alice's restaurant. You can get anything. Okay, so pick some kind of a model, any time in the future, and that model, you're supposed to find a heat balance drawing in the literature. You got 2 weeks. Alternatively, you can use the numbers from your supercomputer output to make your own heat balance drawing. They have to satisfy the conservation of energy. $1,000 says you can't do it. And let me tell you why those bets are safe. You got a bunch of people at the IPCC that come from wholly different backgrounds, and they know you got expertise in this, you got expertise in that, and so forth. And everyone just kind of trusts one another, and they don't talk to each other. So the first thing I'm going to talk about here is the equilibrium climate sensitivity. And by definition, the sensitivity is a temperature. It is the temperature rise to be expected from a doubling of CO2. Okay, so the ECS, according to the IPCC, is that the most probable value is 3 degrees. In other words, if you double CO2, the temperature will eventually rise by 3 degrees. But Stefan Boltzmann steps in and says, if the temperature goes up by 3 degrees, the surface must radiate 16.7 watts per square meter more than it does right now, or did in 1850 to 1900. We remember going back to pre-industrial, post-dinosaur. IPCC says that the very likely range is 2 degrees to 5 degrees C, warming due to CO2 doubling. And that would give us 11.1 to 28.1 watts per square meter increase in surface emission. Caused by 3.7 watts per square meter increase in the greenhouse effect due to CO2 doubling. Remember the right-hand side of that equation? Those two changes are supposed to be identical. So anyway, you can ask your climate guru, did you know that the word gullible's not in the dictionary? That passes for humor where I come from. What? You increase the ability to stop infrared from leaving into outer space by 3.7 watts per square meter, but your model says that you're going to have an increase in temperature such that you have somewhere between 11 and 28 watts per square meter leaving the surface. That's in excess of what we have now. Put it in picture, there's your 159. That remains constant. Doubling CO2 adds 3.7 to the net IR blocking. 159 plus 3.7. But the 3-degree temperature rise would cause 16.7 more watts per square meter. It's a physical impossibility. It cannot happen. Now, a lot of people think that the laws of physics are polite suggestions. They're not. They're inviolate. Well, anyway, IPCC's models don't generally refer to equilibrium. Those graphs that they showed were, well, that's what happens versus time. They didn't get to the final equilibrium when, just wait till the end. Okay, so we're going to take a look at those things. And I'm going to show you this graph that's copied from AR-6. You notice that you can read the dates there. Notice that you can't read any other numbers. You notice that, right? They like to have low contrast micro fonts so that you don't look at the numbers. Anyway, the upper graph up there talks about the CO2 emissions. It's the same graph I showed before, except in the graph I had shown before, I had put in readable numbers. Okay, but down below we have 5 different examples, and these are called SSPs, shared socioeconomic pathways. That has replaced RCP. And the SSPs are followed by a 1, a 2, a 3, a 4, or a 5, according to those 5 different scenarios about how much CO2 we would be emitting worldwide. Then there's a dash, and then there is the radiative forcing after that. Well, I'll get to that. You'll get to see it a little bit later. Don't worry about the fact that you can't read it, because I'll show you one you can read. In any case, the graphs down at the bottom, the little bar graphs, show you the consequences, the total, the amount due to CO2, the amount due to other gases, and the amount due to albedo. Albedo is just the reflectivity of the Earth, which is presently about 30%. Okay, these are the numbers. SSP 1-1.9 means 1.9 watts per square meter radiative forcing from all causes. It goes down the list and down the list to the 8.5 there. You know, my father is a broken record and my mother is a broken record, but I'm all right. I'm all right. I'm all right. Okay, now we're going to have a look at one of those, or in a minute. What do I mean by the radiative forcing due to all causes? Cause 1 is the change in atmospheric CO2. Back up. Did it go backwards? Okay. Cause 2 is the changes in other greenhouse gases, including water vapor, methane, nitrous oxide, ozone. Some people think ozone is the parking lot in the campus. Cause 3 is a change in the amount of sunlight reaching the orbit, and the IPCC takes that to be 0. Cause 4 is any change in the albedo, which is the reflectivity of the planet. Okay, now we'll take a look at SSP 3-7.0, which was the 4th graph over that you saw on the right there. Up at the top, SSP 3-7.0, the Model 3, that's SSP 3, with the total radiative forcing by 2080 to 2100, with respect to 1850, is 7 watts per square meter. Now, I'm going to add a scale. This scale right here that I added is the increase in the surface radiation in watts per square meter. So we have 7 watts per square meter supposedly able to block 20 watts per square meter increased radiation from the surface. Okay, somehow that's supposed to block an additional 20 watts from going into space. Want to buy a bridge? I'll show you a little bit more about him. Anyway, what's the meaning of the bizarre results? Whenever the increase in surface radiation exceeds the increase in the greenhouse effect, remember, we're talking of a disequilibrium here, the radiation to space increases. And if the radiation to space increases, that means we're in a cooling period. So how can a minor increase in the greenhouse effect cause the surface temperature to rise so much that it now has to be cooling rapidly? Only the IPCC knows for sure, or maybe their hairdresser. Any geezers here remember those ads? Okay, now we're going to take number 1 of those charts, the one way over on the left. It's the lowest CO2 increase caused by the most intrusive, well-intentioned, of course, governmental prohibitions. And here it is. Model 1-1.9. 1.9 watt per square meter additional blocking and 7.6 watts per square meter increase in surface radiation. It ain't gonna happen. They get the George Santos Award in resume embellishment. Okay, now here's Al Gore. This is the kind of iconic picture of him walking in front of the graph showing the temperature and the CO2 going up and down together. And if you look at the numbers from CO2 and you calculate how much radiative forcing comes from CO2, it's in the range of 2 or 3 watts per square meter. But the increase in surface, or the change in surface emission, is somewhere around 30 to 40 watts per square meter. The climate scientists were not asking, where did the CO2 come from to cause that warming? Where did the CO2 go so as to cause the temperature to decrease? Now, you do not have to be a whiz kid to ask those questions. Somebody who's pushing a 60 IQ to the limit is going to know to ask those questions. Now, you don't have to be brilliant, but the climate scientists were silent. It takes a little bit more sophistication to ask, well, how did the Milankovitch cycles cause the CO2 concentration to change before the temperature did? Why did the temperature start to decrease when the CO2 levels were high? Why did the temperature changes occur before the CO2 changes? You believe in retroactive causality? Posthumous suicide, anybody? Don't worry, honey, I'll take a pill in the morning. So here's a take-home message. The IPCC does not, and I repeat, not apply the Stefan-Boltzmann equation to their results. Therefore, they cannot construct heat balance equations. You, however, must do so, and here is your equation. If you're not writing it down, remember, I'm a professor. Emeritus, which means out of merit. Write that number down, write the equation down, and I'm going to show you how to use it. You're going to apply it just for example, just to show you can do it. Choose that temperature and see if you get the right I. If you don't, go back and get it again. The easiest way to do it, by the way, is to use Excel. And what you use in Excel to get 5.67 times 10 to the minus 8 is you type 5.67e minus 8. And to get 289.45 to the fourth power, you 289.45 caret 4, and it'll work. In calculators, you use 5.67 EXP or EE8, and then change the sign with plus minus. You can do it. Okay, we going? Okay, now just apply it to some other temperature, like a 3-degree rise. Subtract to find out the increase in the surface radiation. You'll find out it's totally incommensurate with what they were saying is going to be the increase in, or the radiative forcing. Now you understand how the world has been conned. Now there are some take-home principles here that I want you to know. Planetary heat balance says that the I out, the radiation going into space, equals the absorbed sunlight. The heat radiated to space equals the heat radiated from the surface minus the greenhouse effect. I out equals I surface minus absorbed sunlight equals I surface minus G. And the radiative forcing simply adds to the greenhouse effect. Now, this is not hard. You don't have to be a PhD. You can fool all of the people some of the time, and some of the people all of the time. And that's enough to set up a multi-billion-dollar climate crisis industry. Thank you for your attention. Dick.